Yes, I was about to say about the recording, so thank you for the recording. So yes, good evening and good morning for US, good evening for Pakistan. Assalamu alaikum. Welcome to our Python class second session, and I am very excited about this. As I was telling earlier before the recording started, that Python is one of the most fa popular languages nowadays, and it is for a very, very good reason because Python is very easy to learn and it has power of uh, creating apps that can be used for artificial intelligence and specifically generative AI, machine learning, and any other AI specific like image detection, object detection, and computer vision. And then you can make games. You can do, it is highly used in data sciences. So you are here to learn Python. So once you learn Python, there are lots of areas you can go and choose your direction of your interest. So not necessarily that you'll only use it for games or for fun only. Having said this, it is very, very important that if you really want to do something of that sort, you understand the basics of programming. And on top of that, then you learn Python. So this whole effort that I'm trying to put here is to make you understand the basics of programming, not any programming language in particular. Uh, the basics of programming are same for any programming language. So that's why I emphasize that you listen to the lecture carefully. If you don't understand anything, if I'm going too fast or explaining to something too much, or maybe not explaining something at all, please reach out, but don't leave anything. Everything is important. All right, so let me start with today's the second session. I assume that you guys have um, already gone through that session one again, and you have done the labs that we did at the end of the session one, that is installing the Python and the Visual Studio Code. If you haven't, please let me know if you have any question, any difficulty doing that, and we can talk about it uh, like other than this class session as well. But it is important that you have that set up because once we get into it, we'll be doing exercises, more work, more practical work than talking. After a couple of few sessions, we'll be working more and doing exercises more than talking. All right, so today's our second session. You already know about myself, so I just put it there just in case anyone new person joined. Like, so I'm gonna skip that. I'm gonna reemphasize on the objective of this course. As I was saying, the main objective and the main objective again is to learn the basics of programming, not basics of Python, basics of programming. Once we are good in basics of programming, we're gonna apply those into Python because that's what we are here for. And then we will explore some pre-built capabilities of Python, which are very, very extensive. And that's what makes it more popular because a lot of things are already done, like very hardcore programming stuff is done for you. All you have to do is just use it. So that's why Python is popular, that you use it for a lot of complex stuff, where the actual complex stuff is done for you already. You just have to use it. And then in this course, we'll be using Python for games. But like I said, if you are interested or if there are more people interested, we can use it for other activities as well, such as artificial intelligence applications, such as video generation or text to image generation or large language models. Those are popular these days. And then last but not the least, we'll work on the project. So today's session will have a recap of the last one, and then we'll see what is program. We'll talk about variables, very important. Again, whatever I'm telling and trying to share here, everything is important. Nothing is like uh like I'm not telling anything which is not important. So if you don't understand anything, stop me, ask questions, ask me after the session, before the next session. Uh, just ask, okay? So don't just assume anything. And then at the end of the like towards the end, we'll write small programs. So that's why I'm saying the more we get into our classes, we'll be writing more programs than talks. The talking part will become less and writing part will become more. So it is important that you have Python installed and Visual Studio Code installed. So a small recap for our previous session. We talked about what computer programming is, which is a way to communicate to a computer. Computer understand only machine languages or machine language, which is zeros and ones. To make it easier for humans, scientists, and engineers develop low-level and high-level languages such as assembly and Python. Python is a general-purpose platform-independent programming language, and if you recall, platform-independent means it can run on any computer, regardless of hardware. Like you can use it on Apple computers, you can use it on Intel computers. So that's why it's called hardware or platform independent. In the next, towards the end of our session, we install Python 3.12.6 from python.org. Then we install Visual Studio Code from Visual Studio, code.visualstudio.com. Once we had that installed, we install the Python extension within Visual Studio Code. And then we wrote our first ever Hello World program in Python. Again, I'm saying any of these tasks not completed yet, please make sure they are completed. If you have any question, any issues, I'm here to help. Okay. So, what is computer program? We are here to learn programming. Programming is derived from program. What is a computer program? We are talking about computer programming. We are here to learn computer programming. And programming comes from program. So what is a computer program? Anyone? So in simple words, last time when we were talking about like we need to communicate to a computer. So basically we are asking computer to do something, right? So when we ask computer to do something, we are actually giving computer a command to, hey, do this or do that. So a single command that we give computer to perform some task is called an instruction. Like we are instructing computer, hey, do this, right? Like we don't say hey, but you're actually doing act. If you look at from human perspective, we are actually asking computer to do something, right? Sometimes when you want to ask computer to do something, which is like more than one step, then you have to give multiple instructions, not just one. So you will have to give computer like, hey, do this, then do this, do this, that, do this, that. Then when computer perform all those instructions in a sequence, then your task will be completed or accomplished. This group of tasks or instruction is called a computer program. Why? Because now all these instructions are related to a single task. Like a single task you are asking computer to do. And all the instructions are related to that task. That's why you group them together and that you call it a computer program. So that's why you don't have to tell every time computer all those instruction one by one. You just call the name of that program. Just like in your college or school, teacher or principal, they don't have to remember your every person in your class by name. They just remember your class. They say class 5A, for example, class 5B, or right? They don't have to remember like 50 student name every time they say, okay, uh, Hassan Idris, and yeah, all whenever they have to talk about classes, they just say class 5A. So they group all of them together and call just one. So the same way whenever you are talking about some similar task, you can group the instruction together and call it a computer program. So let's see a very real world example how you would instruct. And take it very, give this example some serious thought, because when you are doing programming, you are actually instructing a computer. I don't know if I have told this already, but remember one thing. We think that computers are smart, but actually computers are not smart. They are, they depend on us, right? They depend on humans to become smart. So everything we tell computer, they take it literally. And if we don't take anything, they don't know. Like, for example, if you don't tell anything, they won't say that's understood, right? You don't, a lot of times when you are talking to a human, you don't have to tell a lot of details because you think that's understood. But when you're talking to a computer, you have to tell everything because nothing is understood. You have to tell exactly everything. And that's what makes computer not so smart. You are smart. Humans are smart. So I have a task. I have a task of asking for example, someone like, let's say your brother or sister or a friend to fill up water from water dispenser or refrigerator and give it to you. This is a task, right? And where that person is, maybe sitting on a couch or a sofa or a chair near in their living room, a few steps away from the refrigerator on the right side, for example. See, even smallest details matter. For a human, a lot of things are understood, but for a computer, it doesn't. And where the bottle is in this example, let's say on the kitchen countertop. And now I have to instruct that person to fetch water. Who will help me? So in previous slide, we see the person sitting on a couch few steps from the refrigerator. And let's say refrigerator is on the right side. And the bottle is on the kitchen countertop, which while walking towards the refrigerator will be on the person's left side. Okay, now I have to instruct that person. Can anyone give me instruction, like how to go about this? Okay, so for instruction that I will give that person is obviously get up, right? Or stand up, let's say. Stand up, right? The second instruction I would ask, or let's say, let's do this way. I am asking this to a person and I'm asking this to a computer. So for example, if I ask this to a person, I say, get me water from the fridge. Okay. The person will get up, walk towards the fridge, pick the bottle, fill it up, and bring to you. Now I'm asking computer to do this for me. Let's say that that is a robot, that guy. So now you have to tell, stand up, move to your right, or walk 5 steps forward, lift your left hand and grab the bottle. These are two instruction in one instruction. You see? These are two instruction, one instruction. Bottle. Step 5 is walk 4 steps forward. Step 6, move bottle and forward and align with water dispenser. Step 7, press button, press blue button for cold water. Until bottle is full. Step 8, row, turn around towards me. Step 9, walk forward 10 steps. Step 10, move your hand forward and hand me the bottle. Okay, so now this is just an example if you see here. Let me go back here in this presentation mode so it's more. So if you notice here, I typed these instructions. These are basically very basic steps if you notice. And even here, I did not provide a lot of details. When you are talking to computers, but they don't even know a lot of things that I have missed here. When you're talking to humans, they know a lot of things. They are smart, but computers are not. But now you can see these instruction set are doing just one thing, which if you call someone, hey, can you give me water? That's it. Or fetch water. You call that whole instruction set with one word, fetch water. Whenever you say fetch water, these are the steps that run through everyone's head that, hey, I have to get up, I have to walk towards the fridge, grab the bottle, and fill up the bottle until it is full, and then move her back to that person and hand the bottle to that person. That's how, yeah, every time you don't have to give all the instruction to that person. All you have to do is just call this program, and these instructions are executed or run in that person's brain, or if it's a robot, in that robot's brain, in a sequence that you have programmed it. So now you see what a computer program is. Basically, a set of instructions specified in particular sequence, are repeatable. So next time you need to run or want to do the same task, you don't have to write all the instructions. You just say fetch water, and the instruction will be executed. Any questions? So if you notice, when you become, you remember this example, because when we will start more deeper exercises in our Python course, you will notice that this is all we are doing. We will be adding more details to it because, like I said, I was still missing out a lot of details. When we are talking to a computer, we are actually telling it a lot of things. You know what? I did this exercise with, in another class with kids where they were here physically present. And I did this exercise with one kid telling the other kid to do this thing, like physical. And when they were doing it, it was so funny because they were asking someone to do something and they were missing out information, and that the other kid was following exactly what he was told, and they were ending up doing something else because the instructions was not there. So that's how computer are dumb. They need to be told everything. So that's what we are here to learn, that how to communicate to a computer, how much detail we need to provide. So what that example that I showed you tell us. The next time I have to do some task, we just need to refer to that instruction set that we just talked about it. And that instruction set will run through those individual instruction again. So you don't have to specify or tell exactly those steps again and again. And that's called a computer program. Okay. The other thing inside those instruction set, if you notice, while giving those instruction set, I knew where that person was sitting. If you notice, I asked the first step was saying stand up because I knew that person is sitting somewhere. So that's the first step, is say stand up. What if the person is already standing up, then this instruction is invalid, right? The person will say, I'm already standing up. What do you mean? So when you are giving some instructions that you need to know the initial state of the person, like what exactly right now he's doing. You need to know what the object is, instead of the object needs to operate. For example, in our case, the object that person needs to operate on was bottle. Where that bottle was? On the kitchen counter. So instructions that we are providing needs to know that detail. What the type of the bottle is. Bottle is a container that holds bottle. Oh, sorry, that holds water. So what is the type of that container? That holds some sort of liquid, right? What type of information or some like thing that it holds? Liquid. That's the type of thing that it can hold. And it can hold like mostly cold. It can hold hot thing too, but we know that it holds something cold. What needs to be done with that object? The operation, fill water. What was the operation here? Fill water. So I'm just telling you what we are required to know while writing these instructions set. That the initial state of the person or the things involved, the subject, the object that on which that we have to perform some operation, the operation itself, what we need to do. Like in this case, we were required to fill the water, and what needs to be returned after that operation, what we are expecting, like once that operation is performed, what will be the result? In our case, it will be a bottle filled with water, right? And then certain things we don't care about. They're happening by something that we don't care about, right? In this, in our case, it was a fridge. It is doing something that we don't know how it is doing, and we don't care about right now. We are not worried that if you are asking your friend or brother or sister to bring you cold water from the fridge, how the fridge is making that water cold is not our concern, right? So this is what we are referring it here, that we are using fridge as like a big black box that does something that we don't know. It just take our input that we say, hey, press blue button and give us cold water. How it is doing it, we don't know, and we don't want to know. That thing we call it interface. So just I was telling you earlier, Python has a lot of such refrigerators installed that just take your input, give you the result. You don't need to worry about how they're doing it. How they're making the water cold, you don't need to worry about it. And that's what makes Python more popular, that a lot of things, just consider this, there are other programming languages out there where you not only have to provide you these steps, but you also have to do the water cooling stuff as well. Just imagine that. All right. If you have any questions, please, you can, write down or send it to me separately. But these are very, very important concepts. So if you get hold of these concepts, believe me, any programming language would become much easier. Okay. So now we are moving towards our one of the most like everything is important, but is one of the very, founding things of any programming language, and we call it variable. And I see you both are from Scratch class, so I believe you still remember what the variable is. If you don't, I am gonna repeat it again. A variable, as name suggests, is something that can vary or change, right? That's simple English, right? Something that can change. That is not same all the time. It can change, right? It's variable. Like for example, weather is is variable. Sometimes it's hot, sometimes cold. It's colder in morning, hot in the afternoon, pleasant in the evening. Variable. So variable is just a fancy name of it for a tag or a way to keep track of information. Like I was giving you example of weather. It can also be given, for example, name tags. We have seen, people put name tags on their desk or on their shirts. In programming languages or in programming, computer programming, for example, we use these tags to store information. And I was giving you example of Scratch. You guys made a game in that. Remember the score variable when you were doing something that gives you points? You were storing that value in this variable called score because that could change. Score was 0 in the beginning of the game, but as soon as you do something good, or as soon as the object of your game was met, you were increasing the value of that variable, right? So variable is something that stores the information somewhere inside computer memory and give you a tag or like a name tag. So whenever you need to access that information, you just use that name tag. You don't need to worry about where computer is storing and what form it is storing right now. You just use that tag. So, since you already know computer only understands zeros and ones, so whenever you store any value, anything, any information, it goes somewhere inside computer memory and is saved as the combinations of zeros and ones. But we have been discussing this since our last session that it is very hard to remember zeros and ones or even understand. Is forget about remembering it. Even if we see it, it's hard to even understand it. So a very fancy way or a good way to remember or understand that information is use a variable. You use a tag, you name it in a way that you remember or understand what it is, and then you store information. And then it's up to computer how it stores and where it stores. Right now, we are not worried about that. When you become a more senior programmer, then you will also, instruct computer where and how to store. But at this stage, all you need to worry about is just store somewhere in the memory and give us a tag. And that tag, we call it a variable because that information can change. So whenever you need to read the information you save, you use the same tag name. Whenever you need to store some more additional information or change that information, you use the same tag. So this is all we worried about in terms of variable. So what is data type? So the information we save. So there are two concepts I want to share today. So there is one thing which we call data and the thing which is called information. What is the difference? You have heard this a lot. I'm sure you must have heard this a lot. Data and information, both. You probably thought that they must be same thing, but they're not. They are and they're not. There's difference. The data is something which is just plain value, which doesn't mean anything. Making sense? No. I give you, let's say, 42. Does 42 make any sense to you? It's just a data. It's just number, right? Data. 42. It's data, right? But my age is 42. That's information. That makes sense? So data is simply what? Some value that doesn't make any sense, right? And when you associate some meaning to it, it becomes information. Another example, 30 degrees. Now, 30 degrees could be anything, right? It's just value. But when say 30 degrees Celsius, 30 degrees centigrade, it becomes like weather temperature, right? Or it could be like body temperature, it could be weather temperature, outside temperature. So see, when you add meaning to it, it becomes information. When it is or knowledge or right? So type of information or type of value that you store somewhere, not somewhere, inside computer memory is called like what type of value you are storing is also needs a computer needs to know that because computer when it's storing and giving you a name a tag variable tag it makes sure that this name tag will not have 0, 1 combination that will have any other type of data, right? What is a data type then? So for example, 42, I mentioned 42 is number, right? So computer needs to know, okay, I'm giving you a name tag for number, but what type of information? Now you say what type of information you're gonna save into it. So you say, okay, I'm gonna save into it. Let's say, for example, I was referring to giving example of my age. So I say, okay, create a name tag for age. So say, okay, I created. So what type of information you will be adding into age? So I say, okay, age will always be a number, right? So you say, okay, I'll be using age name tag for storing my age, which is a number. So I say, okay, then age name tag will be of type numbers. If you start adding A, B, C, D into age, computer memory or computer will say, hey, this is not fair. You said you will store numbers. Now you're giving me names or letters. This is not fair. I'm not going to accept it. So that's why data types are very important to understand. That's why you need to understand what information you want to store inside computer uh, memory, right? So that's why it is important to understand the difference between the data and the information, that you know what information you are going to store in the computer memory, then you decide what type of data it will be. Because when you link both of them together, that you know what would be the type of that data, right? I hope you understand. If you don't, please ask questions. I'm here. Sometimes you just that information is just single characters. Sometimes it is yes or no, right? If you know, you must have seen some questions when you are asked, do you want to continue yes or no? So those sort of data type is only yes or no, right? So all those sort of data and information requires you as a computer programmer to tell computer, hey, the information I'm gonna store inside your memory. So I'm giving you this name tag, but the information I'm gonna store in this will have numbers or will have characters or will have the string of characters like many characters like your name, or it will have decimal numbers, right? So computer needs to know, or it will only have yes or no type values. So now you can think what I was saying earlier, the computer is dumb, right? It needs to know each and everything. It can never settle on it is understood on that, you cannot assume just like you would with any other human. Not to worry about these slides, but just to give you some insight that available data types or supported data types inside Python, they're, similar to other programming languages, but right now we're concentrating on Python. The Python supports these data types, and this is how you specify them. And not to worry about all the other that you see. Don't worry about those. We're gonna see when we will start using those in our example, it will make more sense. Right now, you just will be using more the string of character types and the numeric types. So these will be our starting point for data types. Of what? Of variables. And variables are what? Name tags. What name tags are what? They store information inside computer memory. So you can access that information whenever you want, or you can update that information. Okay? All right. So let's come to our lab for today. We'll be writing a small program where we'll be using variable and we'll be asking to add. Uh, to add two numbers. See, the task is add two numbers. So we need to write a computer program that will add two numbers. See, read carefully. Write a computer program that will add two numbers. The reason I was giving so much emphasis, so you understand what our goal is, right? All right, so new text file. This is my Visual Studio Code. I already showed you in my last session how you install it, how you do the extension and everything. Like I said, please rewatch that session again. We have also given you the shorts, so you only watch that short, how to do that. Even after doing that, if you have questions, please reach out. So I have my Visual Studio Code open. I select the file new, select the language here, which I will say Python. Okay, which is untitled. I close this one. Just save this one. This one is untitled. So let me save or save it. Oh, sorry. It is saving. I'm gonna say session 2 underscore lab 1 underscore add two numbers. Okay, that's the name of this. This is the name. Okay. The first thing I will do, if you want to add some sort of references or comment inside your code, and it is very important sometimes because it happens when you're typing something in your code and you need to add some comments so you remember what you were doing, or you want to add titles of program, anything that you don't just want to put it there just for your reference, not for Python to start reading and giving you errors. You do it by this. You add this hash or hashtag and say this program adds two numbers. So this is called commenting. It is very important for programmers when especially when you're writing a larger programs, you start doing this so that you don't, next after a week or so, or sometimes it happens that you don't see a program for a while, and then when you come back, you forget what you were doing. So these comments help you understand that, oh, this is what I was doing. Okay. So I am creating a name tag. I say number equal to 1 point number 1 and number 2 equal 5, right? So I created two name tag or variable. Okay, you can call it anything. The only rule here is that it should start with alphabets of A to Z, and then you can add numbers to it if you like, special character, anything. Special characters like at the rate or hashtag like this, because if you start with hashtag, it will say, oh, it's common. Okay. So number 1, which is my variable 1. And like I said, you can add comments here. This is my first variable for storing the first number. User's memory. Okay. Now this is the second. This is my second variable for storing the second number inside computer's memory. Okay. So this way, I'm just showing you when you put comments like this, whenever you come, like maybe after a week or so, you'll remember, oh, that's why I created this variable. Oh, that's what I'm doing. So you have to choose the balance between how much you want to add, okay, so like comments, if you don't want to add too much comments and you don't want to like not add comments at all, these are called comments. Okay, so I am creating another variable which I call it sum. I say num1 plus, oh, it's number one plus number two. Okay, and then I say display. If you remember from last time, for displaying, we use print the sum, and don't worry about a lot of things that I'm doing with like what's the print is function, all that we'll get to know, in our classes. But for now, just see if I want to print some value out of a variable, we use it like this. The sum of curly bracket 0 and curly bracket, not square bracket, curly bracket 2. Oh, 1 is curly bracket 2. Dot format number 1 comma number 2 comma sum. Okay, so like I said, don't worry about like the syntax. Just for now, just keep following. And I'm gonna, this session is being recorded, which will be shared. I'm gonna copy paste this program in our chat as well. We have completed this. Let's see what happens. When we run this, so the number of 1 and 5 is 6. Okay, this is our results here. You can change that 6 and 7. Then sum of 6 and 7 is 13. Okay, so our program is running. The only thing which I don't like about this program that every time I need to change this numbers, I have to type inside program and then run it again. So it's not much value, right? So let's try another program here. So let me put this comment here. I can put this. Okay. September 9th. And I'm going to copy paste this in our group. Okay. So you guys will have access to this. And then we'll go another short program. And then we'll be done for today's session. Okay, so we save this and our I'll do new text file, say select Python. Okay. And I'm gonna close this, save this as, so this will be my lab 2. The lab 2 will be add two numbers with user input. Okay. All right. So we can do this again. Comments. It's good to add as much, not too much, not too less. Store input numbers. Now in this variation, in this lab, I'm going to do the same add, but this time I'm going to take input from users. Okay? So that way it will add the numbers we will enter. Okay? So I'm going to start with number variable, number equal to input, enter first number. Okay? Our second variable, input, enter second number. Okay, this is our input, and we can put comments. First, where to store value entered by user into the member. Just to save time, I'm gonna copy paste this. I know we are over time a little, so I'm gonna be fast. Store value entered by the user. Okay. Now we need to add these. From here onwards, the program will be similar. Add the two numbers entered by the user. Okay. Same way, sum equal to number 1 plus number 2. Display the sum. Here, we're going to use a print function. So this print function, if you remember, it's doing something similar to what that refrigerator did. It's you're just pressing the button for blue button and it's giving you the cold water. You don't need to worry about how. So this print button, oh, so it's not button, this print function, we call it function. Function is something that you value and it does something and you get the result. Okay? We don't need to, and when we learn more in other session, we can create our own functions as well. But for print function, we don't need to worry about how it is printing on your screen. We are just providing it, let's say, the water bottle, pressing the button, and it's giving us the cold water. In some like water dispenser, if you recall, there are blue button, there's red button, and there's just black button. So if you press the blue button, you get the cold water. If you press the red button, you get the hot water. If you button the black button, you get just regular water. So it's same way, depending on what you are giving to that function, you're getting the respective result. Okay, format number one, comma number two, comma sum. Okay, now we will run our program. This one. Save it first. Save. Always save your work. All right, so this time it is asking me to enter first number. I say 5. Oh, not here. Here. 5. It's a enter second number. I say 8. Okay. And it says the answer is 58, which is wrong. That means I did something wrong somewhere. Okay, so I am doing some mistake. See, this is where I am doing some mistake somewhere. Because what it did, it basically add like join 5 and 8 rather than adding the numbers. Okay, so let me double check. Okay, so you know what happens, and I will explain to you later. When I was entering the numbers by the user, the computer thought I am entering ABCD or strings, right? And I entered numbers. So even though I'm entering 5 and 8, but it is taking it as characters or ABC. So instead of doing some math operation, it's simply join them together. So it's just join 5 and 8 together rather than uh, performing math operation. So I have to tell computer again, see how dumb computer is. You have to tell each and everything. Hey, this is a number. Hey, this is a number. This is not a string character. Okay, so please make sure you add them. Don't join them. Okay, let's try again. 5 plus 8. Now it's at 13. See, you just saw an example of how some computer is. It literally takes everything as you say so. I had to tell explicitly, hey, the numbers you took from users are actually numbers, not ABCD, or they're not characters. Okay? And all these things will start to make more sense when we do more work on data types, uh, type conversions. Like you can take input as like characters, but then you can ask computer to convert those characters into numbers or numbers into characters, all sort of things. But this was a very good example of like how specific you have to be when you're talking to a computer. So this and the previous uh, instruction set we saw, it's called computer program, and we use a variable to store uh, values inside computer memory. And why is variable? The value can change. We've just saw that. The first time the program runs, the number one has value 5. Now the next time it is running, the number one has value 7, and number two has value 4, and the sum is 11. So see, the values inside varies depending on what users. That's why they are called variables. These variables, again, are just name tags that human programmer use to store information inside computer memory so that whenever they need to access that information, they use the same keyword or tag, and computer will bring that information from the computer memory. And when they need to store that information back inside the computer, we use the same tag to tell computer, hey, take this back and update that information with this value. All right. So this concludes our session 2 for today. We covered 2 labs today, although there are so many things we can do, but just a quick recap. We did talk about previous session. We talked about computer program, what it is. We see how we can create an instruction set, how to actually create instructions, how to actually instruct someone. It's the same principle that is involved in writing a computer program. What are these things that we need to note before writing instruction set? Then we talked about what a variable is. Then we talked about what the data type is. During data type, we also discussed difference between data and information. Again, data is simply values. Information, when you add meaning to those values, that becomes information. We briefly looked at supported data types inside Python, but we're gonna use only few incoming labs. Um, as we go along further, we'll be using other data types as well. But for now, for upcoming session, we'll be using only the basics one. And then we did 2 labs today that for the first one, I copy pasted the code as well. Let me copy paste the uh, code for the second one too. Uh, please let me know if you have any question. Uh, any questions, please? Let me know. I'll give you 1 minute. I think there are no questions, I believe. So we can conclude our session here. Okay, so I'm gonna copy paste the code in the chat. They are in the video as well. Anyone wants to refer to it. But anyways, thank you for your time. We'll be covering more interesting topics in our next class. And until then, take care. Lapis.